Hi dear friends, good morning to all. Myself, Fybsc, Assistant Professor, Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Jawar, District Palak. Dear friends, in the last part of the video, we started the topic chemical kinetics. Dear friends, I already revised about this topic and we have seen that the most of the basics of this topic was included in your 11th and the 12th syllabus. Based upon the same topic, in the last part of the video, we have started this topic and we tried to study about the concept of chemical kinetics, also the need of study of chemical kinetics in the field of chemistry, because the drawbacks of chemical thermodynamics can be overcome by means of this branch entitled as chemical kinetics. And already in the last part, we studied about the definition of chemical kinetics is that the branch of physical chemistry which deals with the study of rate of reaction, factors affecting rate of reaction, that branch is called as chemical kinetics. And based upon the same, we also tried to study about the rate of reaction, how we can define the rate of reaction. At the same time, dear friends, in the last part of the video, we studied important factors which can affect the rate of reaction, means the rate affecting or the factors affecting rate of reaction. Today, in this part of the video, we are going to study about rate law and the rate constant with its significance. How can we define the rate constant with the help of rate equation stated by means of rate law? And from the rate constant, how can we predict the rate of reaction? It means that how can we define the significance of rate constant? Before going to discuss about the rate law, I would like to revise about the last part of the video, because in the last part of the video we have studied about the rate of reaction, and according to the definition of rate of reaction, the rate of reaction is the change in concentration of any reactant or the product in unit time because we know that as the reaction proceeds, the concentration of reactant decreases while the concentration of the product increases with the increasing time. It means that during the course of the reaction, as the time increases, the concentration of both reactant as well as product increases, and the change in concentration of any reactant or the product in unit time is called as rate of reaction. And dear friends, in the last part we considered simple chemical reaction in which A is the reactant, it gives the formation of product capital B. What happens as the concentration of reactant decreases, so change in concentration of reactant is dCA and the change in time is dt. So change in concentration of reactant A to the change in time is called as rate of reaction, and this negative sign indicates the decrease in concentration of reactant A. At the same time, the concentration of the product increases, the change in concentration of the product indicated by dCB, and dt is the change in time, and this change in concentration of this product or the increase in concentration of product to the change in time is also called as rate of reaction, and this positive sign indicates that the concentration of the product B increases. So dear friends, here it is possible to define the rate of reaction in terms of concentration of reactant also and in terms of concentration of product also. Dear friends, in the last part of the video, we also tried to define the various factors which can affect the rate of reaction, and the first factor is the temperature, and we found that the temperature or the rate of reaction is directly proportional to the temperature of the reaction, and it is observed that as we will increase the temperature by 10 degrees Celsius, there will be increase in the rate of reaction by 2 to 3 times, Again, we found that the rate of reaction is also directly proportional to the concentration of the reactant, that the same that we are going to discuss in the rate law today. And it also affected by means of in presence of the catalyst. Generally, in presence of catalyst, the rate of reaction increases. The particle size also matter, and if it is found that if smaller is the particle size, then greater will be the surface area, and hence greater will be the rate of reaction. And the last one is the concentration of the product. Concentration of product is also responsible to affect the rate of reaction if and only if this product catalyze the reaction, or this product is responsible to form the reactant again, then this concentration of product can decide the rate of reaction. Dear friends, today in this part of the video we are going to study about the rate law. What is this rate law? How can we define the rate law? And what is the significance of rate is also important today in this part of the video. Dear friend, this rate law is proposed by means of two scientists, Goldberg and Wag, and this rate law can be stated as simple or simply the rate of chemical reaction at any time. It means at any instant, rate of chemical reaction at any instant in the sense any time, is always directly proportional to the molar concentration of reactant or molar concentration of the reacting substance at that instant. Is very important. It means that, as you know, as the reaction proceeds, as the time increases, the concentration of the reactant decreases. It means that according to the rate law, rate of chemical reaction at any instant is always directly proportional to the molar concentration of the reacting substance at that instant, not the particular concentration, because the concentration of the reactant always changes during the course of the reaction, and particularly the concentration of reactant decreases during the chemical reaction, as concentration of reactant and the rate of reaction, these are directly proportional. It means that the rate of reaction also decreases with the concentration of reactant during the course of reaction. Remember, this is very important. It means that we can conclude simply, as initially the concentration of the reactant is greater, hence rate of reaction will be also greater, and at the end of reaction, at the concentration of reactant is very smaller, is negligible, then the rate of reaction will be also very smaller, because this is according to the statement stated by Mr. Pendi's Goldberg and Wag, which is entitled as rate law. So rate law indicates the rate of chemical reaction at any instant is directly proportional to the molar concentration of reactant or molar concentration of reacting substances at that instant. Suppose for that purpose we will consider a simple chemical reaction in which A is the reactant and which it gives the product capital B. Suppose here C suffix A is the concentration of the reactant A at time t, then according to the rate law, what rate of reaction at any time is directly proportional to the concentration of reactant, and here it is Ca. So rate of reaction can be defined, can be written in the form of equation in terms of concentration of reactant as dCA by dt, change in concentration of reactant, or decrease in concentration of reactant A to the change in time, and this negative sign indicates there is a decrease in concentration of reactant. So minus dCA by dt is directly proportional to the concentration of reactant. So this minus dCA by dt is the equation for rate of reaction. Already we have seen in the previous lecture, in the previous slides, and this according to the rate law, rate of reaction is directly proportional to the concentration of reactant, and this is rate means minus dCA by dt. So this equation shows how the rate of reaction is related to the concentration of reactant. So this equation indicates how This rate of reaction is related to the concentration of reactant, and this equation is called as rate law, or simply it is called as the rate equation. So rate equation is the equation stated by rate law, which shows how the rate of reaction is related to the rate law. So dear friends, from the rate law we can conclude here, or we can say that rate of reaction of any chemical reaction is always directly proportional to the molar concentration of the reacting substance, that is Ca, for simple chemical reaction. So here this proportionality sign can be removed, and instead of this proportionality sign we will take some constant. So this rate of reaction will be equal to K into concentration of reactant. So minus dCA by dt into constant is equal to constant into the molar concentration of reactant A. So this proportionality constant K in this equation is known as simply a rate constant, or it is also called as the velocity constant, or sometimes it is also called as specific velocity constant. It's very simple to define this velocity constant, rate constant. Definitely it has some significance also. It gives a particular information also that we will discuss here. But here we are also interested to define the definition of this velocity constant, and this equation for this according to the rate law we got minus dc by dt is equal to k into, means velocity constant or the rate constant, into concentration of reactant. Suppose here if we will consider the concentration of the reactant is unity, means concentration of this A will be equal to 1. So this equation can be written as simply rate of reaction is equal to minus dC by dt is equal to simply K. So because Ca is equal to 1, that we considered here, so here it means that this rate constant K is equal to what? It is numerically equal to rate of reaction. So this rate of reaction is equal to what? Rate constant. But for that purpose what we considered? For that purpose we considered the concentration of the reacting substance is unity. Then the rate of reaction is always equal to rate constant, and from this consideration definitely we are able to define the definition of rate constant. So with the help of this condition, or with the help of this unit concentration of the reacting substance, we got simply equation rate of reaction is equal to the value of K, and that's why here from this we can simply define rate of reaction is equal to the rate constant. So rate constant K from the above equation can be defined as it is numerically equal to the rate of the reaction, when all the reactants are at unit concentration. It means that if we will keep the concentration of all the reacting substance is unity in the sense 1 molar, one formula like this. So this will be 1 millimole, 1 mole. So this is called a unit concentration. Then the value of rate of reaction can be considered as the value of rate constant, or the whatever rate of reaction that will be equal to the rate constant. So what the information is given by the rate constant, how it tells about whether the reaction is rapid or not, and here this is called as significance of rate constant. So here from the value of K we are able to predict the rate of reaction, as here it is observed that rate of reaction is direct, or it is equal to the rate constant. It means that rate of reaction is directly proportional to the value of K, and from the value of K, that's why it is possible to predict the rate of reaction. And it is observed that the high value of K, or it is concluded that the high value of K indicates that the reaction is rapid or the reaction is fast, and low value of K indicates that the reaction is slow. It means that from the value of K we can predict whether the reaction is fast or the slow. It means that it is possible to predict the rapidity of reaction from the value of k, and we can compare the rate of reaction on the basis of value of k at different time intervals also. And that's why here rate constant or the value of rate constant always changes with the time, because what happens actually as the time changes, concentration of the reactant changes. As the concentration of the reactant changes, rate of reaction changes, and as the rate of reaction changes, definitely the value of k will also change. And it means that the value of rate constant always depends on unit time, or the value of rate constant always changes with the change in time during the course of the reaction. So dear friends, today in this part of the video we tried to study about the rate law. With the help of rate law, we tried to study about the rate constant. We have defined its definition, and definitely we have seen its significance also. So dear friends, today in this lecture, I think you got a clear idea about the rate law, rate constant, and the significance of rate constant, because these are the very basic important terms in the study of chemical kinetics, and based upon these terms we are also going to discuss about, we are also going to study about the next concept in the chemical kinetics, which are called as order of reaction as well as molecularity of reaction. So dear friends, in the next part of the video we would like to study about an important concept in the chemical kinetics called as order of reaction and chemical and the molecularity of reaction. At the same time, we will be interesting in order to distinguish between order of reaction and the molecularity of reaction. So dear friends, thank you very much to listen me. Thank you. We will resume in the next part of the video to discuss about the order of reaction and the molecularity of reaction. So thank you very much.